Hey everyone, I'm so excited to be here today to speak to all of you about our experience building machine learning at Careem. I'm a staff software engineer in Careem. I'm leading the machine learning infrastructure team. And in today's talk, I will be presenting my team and the work of some other awesome colleagues we have also. So let me start by a question. Who has ever traveled to the Middle East here? To Jordan, Egypt, Morocco, or anywhere else? Awesome. And who has ever used a ride-sharing service to go somewhere, maybe? Okay, seems similar to the number of people who went to the Middle East. Cool. So in today's talk, I'll be covering different things. We will start by a sneak peek into AI at Careem. I will also give you some context about what we are doing. And then after that, I would like to introduce you to some of the motivation behind our decision to build our own machine learning platform. And then after that, we will deep dive into the design, the architecture, the decisions we take while building this platform. And then I would also like to discuss with you some thought about the importance of scaling the usage of machine learning. And then finally, we'll wrap it up by sharing some lessons that we learned during the journey of developing our platform. So Careem is the leading technology company in our region. A region that extends from Morocco to Pakistan and from Turkey to Sudan. We are actually operating into multiple verticals, from ride-hailing to payment and food. And we are serving more than 33 million customers across more than 100 cities. With this great power comes a great responsibility. Our mission, the reason we exist, is to simplify the lives of people and to build an awesome organization that can inspire the whole world and the whole Middle East. And with this great purpose comes also a great reliance on AI to enhance our customers and captain behaviors. You know, we call our drivers captains. And we do this through applications like ETA prediction, price estimation. We also rely heavily on machine learning in order to make sure that our platform is secure and safe. We use anomaly detection, we rely on fraud detection and also prevention, and many other applications that can make sure that our captains who are riding, taking our customers, are feeling safe, and that also our customers are feeling the same. And finally, we are a two-sided marketplace. And so we need to use machine learning to make sure that this platform is very efficient. We do this through supply forecasting, demand forecasting, as well as other applications like smart dispatching and peak. Okay, but we need to be an AI-driven company. And as you know, a mall cannot be considered an internet company just because they have a website on the internet, right? The same way, a company cannot be an AI-driven one just by having a couple of models deployed in production. In order to have a scalable AI ecosystem, we need to have these four pillars. The first one is big data infrastructure. We need strong data infrastructure that can allow us to process and handle terabytes of data reliably and smoothly. You know, we need different technologies. We need, I'm sure you heard about Flink, Spark, Hadoop. We need all of this in order to be able to handle all these huge amount of data we are having. We also need a data warehouse, a trustworthy, governed, and documented one. And we need scalable machine learning infrastructure. And finally, we need the awareness. The awareness about AI across the whole organization. We need everyone to understand what's AI. How can they use this? How can they build the value for our customers through machine learning and AI? In today's talk, we will be focusing more on the third pillar. Cool. When people think about machine learning, do you always think that the development journey of your machine learning system would be centered around the model development? While in reality, most of the time, gets actually spent in all the other stages. Let's go through some of the challenges that you might face while building your next machine learning system. Let's start by data. And in our case, we are talking about lots amount of data, millions and millions of records. We need to handle this data. We need to extract our features. We need to clean the data. We need to create our own data set. And so we need all the power that can allow us to do this. We also need to train a model. And when you are dealing with this amount of data, training itself becomes very complex. We need to have also multiple models. We need to tune all of these different models. And reproducibility comes as another challenge. How would you easily reproduce the same results when you have different parameters, you have different settings, and you are not having any versioning for any of this? And after that, normally you would love to take this to production. And this could be a very huge step, especially if you are using totally different technologies for experimentation and R&D, and a different set of languages and technologies for production. For example, let's say you are writing your algorithm in R, and then you decided, OK, I want to take this to production. I need to rewrite this again. This has to be in Java. This has to be in Scala. So this is normally a big friction that prevents you from going smoothly to production quickly. And then finally, we need to deploy this. We need an API, a normal software engineering API. But with the development of this API comes also all the other challenges of software engineering. If you ask any software engineer, like, how would you build an API? Is it easy? He would tell you, yeah, it's easy, but I need to take care of like a couple of different things. This API has to be offering a low latency, high throughput. We need monitoring, alerting, auto-scaling, and we need fault tolerance. And there are other many things, like we need security, et cetera, et cetera. But like these are only some of the challenges that you will face while building your machine learning system. Fine. But what will happen after we even deploy this? We start facing a different set of challenges. In our case, at least, our business is evolving all the time. We are operating in multiple countries, and the markets are always changing. The number of trips is growing. The number of people is growing. People are changing their behaviors. There are different events. All of this is going to affect the performance of our models. And so what? We need to continuously refresh these models. We need to keep retraining. We need to keep deploying these new models. And we are not talking about just one model. We are talking about every single model we are having. And we need to understand when the model starts degrading in performance. So we need monitoring for the performance of this model in production. And we need alerting whenever something happens. And we need A/B testing. We need to A/B test between the existing models we are having, or maybe you have a brilliant idea for solving the same problem, but you want to try these two different algorithms and see how would they perform in production. Because testing outside of production is totally different when you really test the model in real data in the real world. And we also want to roll this model out to all of our different cities. If this model is performing in Cairo, then maybe we would love also to roll it out to some other different cities. But which cities are ready for machine learning? Which cities have enough data? Which cities have enough data that can also be sufficient for having a good performing model? And even if we decided to roll it out to all the cities, how we are going to handle all this huge training pipeline that we need here? Are we going to use the same algorithm? Maybe we'll need to have different algorithms for different cities. And we need to tune these different algorithms based on the data from the different cities. Still, all these changes have to be also reflected in production. So are we going to have an API for every new model we create? Or are we going to basically update the same API, the same microservice we are having? And how are we going to do this smoothly without having to spend lots of time maintaining? And for all of these reasons, we decided to invest in building our own machine learning platform with the mission of simplifying the end-to-end experience and reducing and decreasing the time between experimentation and impact realization. Let me walk you through how we are handling the different steps of machine learning. Normally, when you are building a machine learning system, you are solving a problem using machine learning, you would go through this life cycle. You would start with formulating your problem, and then you will work on your data. It will take you a lot of time. You will create the features, craft them, clean, etc. And then you will train a model. We will test it. And then after that, we will deploy it. And normally, we don't stop here. This is a continuous process. Like, we keep doing this all the time until we really have a solution that can literally solve our problem. Let's see how we are handling the first stage, dataset generation. We allow our different customers to access different data sources. This could start from real-time data. We have lots amount of data that's coming in real time. This could be the positions of our captains. This could be the customer feedback that's coming all the time. We also want to give them access to our data lake, to our Hadoop infrastructure, where we are storing terabytes of historical data. And our feature store, where you can find the different features that were used to train the different other models. And this can save you a lot of time, actually. And in addition to this, you get to use a powerful and distributed technology. In our case, we rely heavily on Spark. So you can either provide your query in SQL or write your code in Spark, or even you can use Python. It depends on your use case, depends on the amount of data you are using, the complexity of the feature engineering logic you are having. And then after that, we store all of this as a versionable data set. And versioning is very important for reproducing the same results again later, if we decided to basically to evaluate a different approach, for example. So this gets stored in a centralized location. And then, normally, you would need to have this running every week, for example. That's why this would be a part of a pipeline that will be running on Airflow. So let's remember this. This will be the first part of our pipeline, the dataset generation. Let's move on to the next step, training. Let's start by the infrastructure, where we offer our users with different Docker containers that are already pre-configured. Everything is installed. You don't have to spend any time preparing your environment. Everything is available. You have access to different libraries, whether it's scikit-learn, XGBoost, CatBoost, FPProfit, like different libraries, etc., or even Spark. And this actually is going to give you infrastructure access to all of these different libraries. But what's even better is that we are offering and giving our user an abstraction layer on top of all of these different libraries. So once they decide to write their own algorithm, they can basically use this abstraction, which is implementing the traditional machine learning flow. You'll find all the things that you will normally need to do, like, OK, I want to split my data, train, test. I want to do cross-validation. I want to write these metrics. All of these things are available through different APIs. And then through this API, you can write the same code, just change between CatBoost and scikit-learn, and that's it. You don't really need to rewrite the same logic and then rewrite a different algorithm because you are just changing the library. And your algorithm will only take a couple of different configurations based on how you would like to adjust its performance and functionality, which also means that we can use the same algorithm to train, let's say, 100 models for our 100 cities. We just need to pass a different dimension. This could be the city. This could be the country. It could be age, male or female. It could be different things. And then based on this, we can train different models. But if we are dealing with all these number of models, it's also very important to leverage hyperparameter optimization. And that's why this is one of the modules that we are also implementing. So you just say, OK, I want to use a hyperparameter optimized version of gradient boosting trees in Cat Boost. And then the training session would start. It will try different set of parameters. And then it will result in a model. Not just a model. In addition to the model, we have an evaluation report capturing all the different metrics about your training, in addition to all the metadata. How much CPU did you use? How much GPU did you use? The RAM. Given all of these different metadata, still reproducibility will be much easier. OK. But what about R&D versus production here? Thanks to the integration between Jupyter Lab and Docker, we are able to give you, as a user, the ability to start working on the same environment that will be available in production from day one. So this means you are using the same APIs, the same infrastructure, the same Docker container. So once you finish, you can just take this, put it in production. You don't really need to wait. OK, so what's after training? We need also to have a pipeline. So this will be the second part of our Airflow pipeline. And this will be very smooth, because this was a container. The one before was a container. Through Airflow, we already have a module which is configuration-based. So you just go to our UI and say, OK, I want to add this to the pipeline. And now you have a pipeline which is going to run weekly to first generate the data set, and then after that, it will invoke training. And this is like an example of some of the reports that gets generated when you train your model. So you can see different visualizations, different metrics, AUC, RMSE, like different metric that helps you understand deeply how did this model perform. You can also compare between different models. You can look at historically how did this model perform in this specific problem, etc. In addition to the metadata about the environment itself. Now, we need to serve our model. And normally, there are two ways we can do this. The first way is batch serving, which is basically we want to run a data set through our model, generate predictions, store them somewhere in some database. This could be different things. So if you see here, if you look at the diagram, you can see that we have our input data. We also have the feature transformation, which is the feature engineering, basically. It's a function. We will take your input data, pass it through the feature engineering, and then the output will be redirected to the model. The model will generate the predictions, and then you will have the ability to decide where to store these predictions. So it could be in a key value store, in a relational database, and then the consumer will just go consume these predictions from the database. But actually, the most common serving in Careem is the real-time serving, the online serving. We have lots of use cases where there are things changing all the time. We have captains on the ground. We have customers who are looking for the ETA. And these people are looking for real-time predictions. So we invested in building a generic configuration-based and modular framework for serving. And the goal here is very simple. We want to be able to serve any machine learning model without having to write any code, only through configurations. And this shouldn't be dependent on a specific machine learning library. So you basically send a request, and then this request gets to the model, and then I get a response. A REST API that you can find implemented normally anywhere. But this has to be very generic, and normally you need to have feature engineering. Sometimes you are lucky, and the training data is exactly matching the data you can expect in production from your consumers, but sometimes you are not. Sometimes you would like to inject a custom feature engineering function that can be used in the production environment. So every time you get a request, it will pass through this custom function, and then the output will be passed to your model. But in addition to this, we also have more features. We have access to real-time data. This could be weather API, for example. Or it could be aggregated data. Let's say I want to look up some data which is aggregated on the user level. So we give you access to look up anything from a key value store, and then given the customer key, you will just go and look up the customer stored aggregated features, and then you will be able to use these features to improve the performance of your model. You also get access to A/B testing. We log the different predictions, so this way we can later be able to monitor the performance of the model in real time in production. And we also have a standard interface for the request and the response. This way, integration will be very smooth because, okay, you will implement it once, and then next time you are using our serving framework, it will be pretty much the same code. We have request batching, so since machine learning are more optimized to handle multiple requests at the same time, so rather than doing it one by one, we basically will batch different requests in one session, and then we will send it to the model, and then we will return back all the predictions. But actually, once we started using the serving framework, we found that we were spending lots amount of time, lots amount of manual work. Why? Provisioning infrastructure, tuning and configuring the serving framework, doing blue-green deployment and canary deployment, monitoring and building the monitoring configurations into our different infrastructure tools. So we decided to invest also in this deployment service. And the goal here is to have a deployment service. You give it configurations, it will go, do everything, use the serving framework, and return back an API, a scalable and production API. So what OCD will be doing is actually, it will provision the infrastructure, it will build the Docker containers, it will make sure that this API is passing by the necessary health checks. We will pass it by latency checks, integration tests, end-to-end testing, making sure that this API is really ready to be deployed in production. And then based on your configuration, this could be a blue-green deployment or canary deployment. We will create all the necessary monitoring links and alerting, and this all will be available in one page for you. And then you have an API. And we also rely on OCD for another workflow. We call it auto-rollout. Auto-rollout is basically about, okay, it's deployed, but who will deploy the next time when we have a new model that was refreshed maybe 1 week after? It will be OCD. Automatically, this will be part of the same pipeline we are having. So whenever there is a new model, it can go directly to production without any manual intervention. Why? Because we have all the stored configurations already. We have stored the configuration that you have passed to OCD. We know the latency SLA that you were asking for. We know also what kind of integration tests you have because of the configuration you have specified. And with this one OCD, we are now able to have our own API, the scalable API we were looking for in a very short amount of time. Okay. But there is actually a big difference between machine learning systems and software engineering systems. Machine learning systems are always evolving, are very dynamic. Why? Because of the data. The data is changing, the models are changing, and so everything around them will also need to change. Always, continuously. And that's why when we look at machine learning system, we don't look at a system which will get created once and then you will forget it. This has to be a continuous process. We have a pipeline, the one we were describing. Once it generates the data, we also need the automation. So we need the checks. We need the quality checks for the different data features. Making sure there are no anomalies, making sure that this data are, if it's flowed, everything has to be flowed. And then once this data is generated, successfully passing the checks, the validation checks, it will invoke the next layer, the training. Once the training goes through, it will make sure, okay, what's your condition? My condition is accuracy should be more than 90%, or that this model should be better than the one in production. So the one in production had an error of 1. I need this to be having an error less than 1 at least. And serving, leveraging the existing infrastructure, what we have been talking about, especially auto rollout. We can take this model to production continuously this can happen without any human intervention. So this is like an example of the API we'll be getting. This is a request, this is our API, and this is a response that you will get. And by investing in all of these infrastructure, we were able to gain lots of impact, actually. What used to be taken maybe a couple of weeks or even more than a month, a long time ago, is now taking us only a couple of hours. There are lots of other gains that we were able to accomplish. But the most important one is we are now able to tap into the compound impact. We are now able to deploy very, very quickly our models, touch our users, understand what they are looking for, continuously iterate on the models we are building. And by doing this, this is unlocking a lot of impact for us. Okay. But we don't really believe that scaling machine learning should stop here. There is another side of scaling machine learning, which is very important, which is scaling its usage. By democratizing the AI usage, by enabling and facilitating the usage of AI for everyone in the company, we can also unlock a lot of potential. And that's why we decided to invest in building the necessary infrastructure to make sure that everyone within the company is able to leverage the benefits of AI without having much knowledge about how is everything working, and also with very limited effort. We believe that this can happen through three main ways. First, AutoML, where different people can get to build end-to-end machine learning systems with very limited amount of knowledge about it. Time series forecasting, which can guide our different business decision takers to be data-driven with the decisions they are taking every day. How? Through looking at the forecast of our different important KPIs and metrics. This could be supply prediction, demand prediction, different actually forecasting use cases we have in Careem. And finally, by having custom-tailored and AI-powered toolings that are addressing different domain problems, we can enable different people, whether in tech or outside of tech, to use AI and machine learning every day. Even if they don't know about the nitty-gritty details of like how is everything working and that this is using a machine learning model behind the scenes, it doesn't really matter. What's important is the impact. So we have a campaign management system. You go, you want to understand which customer should basically get these campaigns. Okay, a machine learning model will do this for you, and it will give you the recommendations. For you, this maybe look like a magic, but it's awesome if you understand that this is happening through our models and thanks to the infrastructure. And this can even expand to more different domains. Let's go to some of the details behind how you can build an AutoML system. So normally, the most important part actually is having a feature store. Why? A feature store is basically a database where you can store thousands and thousands of features. And these features can allow you to focus on your business problem. Normally, if you developed any machine learning model before, you know that it's very time-consuming to develop your features, to craft them, to clean them, to come up with different data sources, to have basically to handle the access problems, handling the size of the data. So if you have access to a database where you can find different features, you will just focus on selecting the features that are relevant to your business problem. And then, given some configurations, we can invoke a feature selection, automatic feature engineering. If it's date, maybe we can try to come up with the seconds, minutes, hour, number of hours. If it's lat and long, this could be the distance, calculating the time, estimated time, different features which could be generated. And then after that, our AutoML system will basically try different algorithms. We'll try to tune all of them, and then it will give us back a ranked list of different models. Some of these models could be even ensembled together, especially if we don't have a hard limit on the latency of our models. And then after that, leveraging the same existing infrastructure that we have been discussing before, we can roll this model out in a few minutes. This is very powerful because you can now experiment with different ideas, with different machine learning algorithms. And you have a problem, you can just go try different things, and then take this model and let it actually touch our different problems and see whether this is going to solve our problem. We will let the A/B test decide whether this is really a solution or not. And this is also lowering the barrier, making lots of people more comfortable to use machine learning and making them more confident that, yeah, machine learning is actually not really as hard and as complex that I thought. So now is the time for sharing some of the lessons we have learned throughout the journey. And let me start by a fact. Machine learning development is a cross-functional work. We have different people who are involved in this normally. Let's start by our software engineers who know best about their different services. You know, what kind of latency should our machine learning model have before integrating it in their service? Do you know that this has to be very scalable? Why? Because we are handling millions of requests. Do you know a lot about their systems? We also have our product managers who understand our different business contexts. They are always looking for the product market fit solutions. They understand the customer needs. And we have our data scientists and machine learning engineers who are the best when it comes to machine learning. They know about the different algorithms, which solution, which technique should be used, if this latency requirement is imposed on them. All of these different people should actually collaborate together in order to have an effective solution. That's the only way this can happen. Secondly, automation. Actually, I think this is one of the most important lessons, because if it wasn't for automation, you won't be able to scale machine learning at all. Machine learning systems by default have a lot of moving parts. Whether it's this pipeline, which is tracking the performance of the API in real time and sending alerts in case of any issues, or it's the other pipeline, which is continuously training your model. There are lots of different moving parts. All of them needs monitoring. All of them needs alerting. All of them needs special care. If you didn't invest, and if we didn't invest in automation early, you would find yourself spending most of the time just taking care of this service, making sure that this is reliable, handling the issue in this other service, doing a manual deployment here, looking at how this API is performing once it got into production. So in order to really have a scalable way to deploy and to experiment with machine learning, you need also to double down on your investment in automation. Finally, while designing your machine learning platform, please make sure that you are taking into consideration the different needs of different people. We have our research scientists who are looking for using different tools. Machine learning is evolving all the time. We have always different new frameworks and libraries and different techniques. And everyone shall be able, of course, to use the right solution for the right problem. And we also have the other machine learning enthusiasts who are curious to use. The big lesson here is that everyone should be empowered and able to use machine learning. And the machine learning we are talking about here is the one which is touching the lives of millions of people. Thank you so much.
Thank you. We have time for questions.
Thank you very much for the presentation. I have a general question about the trade-off between making things really configurable or coding them yourself. So if you put a very strong emphasis on configuration, at the end of the day, your configurations might look like the programming languages itself, and it's not very general, and it has to be learned from the scratch. So did you face that kind of trade-off, and what was your idea about that?
Yeah, that's an excellent question. Thank you. So actually, it's always about this basically balance between flexibility and ease of use. You want to build something which is flexible. You can use it for different things, and at the same time, you also want to have it easy, because if, as you said, if like you have like lots of different configurations, it will be super hard for people to use it. So the way we actually are trying to handle this is by building things in a modular way. So this way, for example, you have different Docker containers, for example, right? Like we were talking about training, and you have different Docker containers that are packaging different machine learning libraries. Let's say you have your own custom algorithm, and you don't want to use any machine learning library. You want to build something totally from scratch. It's yours, and you want to have it also like being trained and served. So in that case, since everything is modular and we have an interface, you can also have your own Docker container. In addition, you have your own Python package, install it inside this Docker container, for example. And then as long as you are respecting the interfaces we are having, you can plug in this container and everything will continue to be working the same. But of course, it's also challenging. Like, I mean, there are like millions of things that you can control. And that's why this is, Careem machine learning platform. It's not the machine learning platform which will be solving every problem. We have like lots of customizations. When I'm talking about, for example, the way we are doing training, we understand that we have like lots of cities, we have lots of countries, we need lots of models to be running in production. And that's why we will take the design decisions, which will also optimize for our different customers and their needs.
I have a follow-up. Thank you. Do you think the company you are working, because your company is working on different versions of a similar problem, does that help with packaging things up in a constant way? But what I mean is, you have some kind of problems that you are going to solve, and it's similar for different cities, right? Some things change, but at the end of the day, you are solving a similar problem. So, does this help when you are considering to move in a more generalized and configurable way? If you were to do different kinds of analytics and data science work, would you follow the same path, or what would you do differently?
Okay, so let me try to rephrase your question. Your question is mainly, was we able to do what we did here and presented here because we had like very similar problems from each other? Yeah. Right? Yeah. Okay, so I don't really actually think that we have like similar problems from each other. We have different sets of problems that like the ones we were talking about. We have anomaly detection, we have fraud detection, and we also have real time, and we have batch. We have some cases where we have like lots amount of data and lots of throughput, and we have others where we don't have the same. But like the way we are addressing this is like the way our team is working. It's working more like as if we are an independent startup. We have like different stakeholders around us. We will go and we will consult them. We will listen to their requirements, and then we will keep prioritizing. Like, okay, this team is looking for this set of features because of this specific use case, and this other team is looking for a different set. Maybe actually there are conflicts. Maybe like this one will take a lot of time versus this one. So we will keep prioritizing, and we will look at it the same way, like any company which is building a generic platform will be looking at. But rather than looking at the whole world, we look at the different demands of Careem.
So we have 2 more questions.
Hi, thank you for your presentation.
Thank you.
On your side with model training, you have like this only machine learning models like XGBoost or CutBoost. Do you use deep learning models, and if yes, for which problems?
We use deep learning, yes, of course. For which problems? Forecasting is one of the areas where we are using deep learning, of course, and neural networks in general. We also use it in fraud detection, yes.
Okay, another question here.
Hi, I was wondering if you can give us any color on your experience with dealing with training serving skew when you're doing this continuous loop of training. How do you deal with that? Okay,
so this is actually happening always like through the code that you write. So whenever you're writing the code, you basically write the training code, but you also write code which is validating your training set, and to make sure that this data set is actually of a certain quality. So whenever you write the code for generating the data set, either before training you can check, or after generating the data set itself on top of Spark, for example, you can have like any certain condition that you want to have. We are not imposing a certain, like a certain logic on every problem. We let people flexibly like write whatever logic will make sense for their specific problem.
What I meant is when you're automatically retraining, how do you make sure your live data matches the training data?
How do I make sure that my live data is what, sorry?
Your live data that you use for actually predicting is, that your training data is representative of the actual traffic that you're getting, because you have everything automated, right? You keep retraining.
But this automation, like it's code, right? So it's a pipeline. You have different stages. So once the data set generation will happen, the next stage will be the quality checks. If the quality checks fail,
I'm talking about when it's in production. How do you check that your live traffic matches?
We don't do training. Like training is basically separate from the production environment. Like the models which are in production don't get trained while they are getting served in production.
Yeah, I know, but they might get wrong answers if the distribution of the features in the production data materially differs from the training data, and you have everything automated, so you might not you would have to refresh your training data set all the time. Is that what you do? Otherwise, you can get out of sync between the training data set and what you're actually predicting on in production.
I'm not sure, to be honest, I'm able to pick up your question correctly.
Okay.
Let's take this offline.
Yeah, sure, of course.
One question here.
Yeah, I was wondering how big is actually in number of people your team, and also the data science team and the company in general who is using your platform. I mean, what is the really number of users?
So my team, you mean the machine learning infrastructure team, right? Okay, so we are 6 people in the team. Data scientists, I think we have like maybe 40, 50, like something like that. And sorry, what was the last point?
And you said you were expanding the use of artificial intelligence across the company.
Yeah.
Using AutoML. So
Yeah.
how many people? So how many people is actually using it that is not in data science, and how many people you expect to use it? How
like exactly, I think I don't really have a number in my mind, but like to be honest, like some of these are dashboards that are available for people, so they can just go and check. But for sure, like most of our growth teams, for example, are leveraging the forecast. So they are like every month they will make sure that they will look at these forecasts that we publish, and then that's how they will learn from it. Like I think most of our data scientists are using our platform, so. This could be like when it comes to, I think, the custom tools, I'm not sure, to be honest.
Okay, let's thank the speaker again.
Thank you.